Here at the United States Army Proving Ground in Aberdeen, Maryland, are some of the weapons provided to the American soldier during other eras of our history. This was America's firepower yesterday. The rifles, the wheels, the armor, the tracks that moved our army and took the battle to the enemy. This is America's firepower today, an achievement in advanced military techniques to meet the swiftly changing needs of our modern army. Today on The Big Picture, you will see how this unique firepower and mobility are developed by the United States Army Ordnance Corps through its dynamic arsenal system.
The United States Army presents The Big Picture, an official report produced for the armed forces and the American people.
The Army's modern arsenals, located in various parts of the United States, have come a long way from the old gun and powder storage depots they used to be back in the early days of our country's history. Today's arsenals are vast engineering laboratories where highly skilled technicians carry on continuous research, development, and testing of the complex weapon systems we need to protect our country. Though the pattern for America's arms is often designed in cooperation with industry, arsenal technicians, because of their exclusive experience in the art of weaponry, direct and control development programs. From the drawing boards come the sketches, the plans, the blueprints, supported by the vast fund of scientific armament knowledge that goes into the planning of a weapon system, from a gun to a missile, from a truck to a tank. Here, the dreams of arsenal design engineers slowly take shape. From the scale model to the wooden mock-up to the pilot model, development is based on research carried on by the Ordnance Science Industry Team, not only in arsenal laboratories, but in various other ordnance establishments, such as the Human Engineering Laboratories at the Aberdeen Proving Ground. Weapons do not fight alone, and in the planning of any weapon system, it is important that the designers consider the human operator. The best weapon is only as good as the man who uses it. How will a soldier react under combat stress? How quickly will he be able to make vital decisions affecting the weapons on which he must rely? Human engineering specialists try to pinpoint these responses to make sure that the fighting man will be able to operate efficiently the complex tools of modern warfare. Ordnance arsenals specialize in development programs to satisfy particular Army needs. Frankfurt Arsenal in Philadelphia has contributed vital military knowledge to our nation for over 140 years. Today, Frankfurt specialists carry on the thread of ordnance skills handed down by generations of arsenal workers.
Here at Frankfurt, one of our main jobs is developing optical and electronic fire control equipment. To hit the enemy with everything we've got calls for hairline precision in fire control apparatus. In one of the best equipped optical research laboratories in the world, lenses are ground for a variety of new weapon systems under development. In this shop, we do optical research on rangefinders, gun sights, and many related instruments, both for the Army and other branches of our armed forces. Inspection of optical equipment requires highly trained personnel who must be able to check out everything from the simplest to the most complex optical system. Frankfurt also develops timing and firing devices, such as fuses for conventional ammunition and for the newest rockets and missiles. Basic research for some of the intricate timing equipment used in our missile program was done here. Improvement in old and development of new methods in production engineering is an important arsenal research activity. Extrusion of brass discs into cartridge casings is performed for test purposes in Frankfurt's engineering laboratories. The operation is typical of arsenal research, which looks for the very best military products for defense at the lowest possible cost to the nation. Once engineering methods have been successfully developed by the arsenals and limited pilot quantities have been produced for test purposes, the plans and the procedures are turned over to industry for mass production for Army-wide use. At Frankfurt's Environmental Testing Center, packaged firing devices and optical equipment are put through various climatic experiments. Because the life of the soldier may be at stake, even with the smallest ordnance items, there is no room for second guessing. Arsenal technicians make certain that long before it reaches the field, equipment will perform as expected under all conditions.
I'm with the Picatinny Arsenal in Dover, New Jersey. Back in 1879, we used to be a small powder depot. Now we've grown into one of the world's foremost ammunition research centers. Because Picatinny is concerned mostly with the development of explosives for the Army, research buildings are dispersed over a wide area, and safety precautions are the rule everywhere. Old and new buildings are equipped with an elaborate network of escape devices. Long safety ramps separate laboratories devoted to research in the newest firepower demands of our armed forces. Ordnance, in cooperation with industry, carries on research in the processing of plastics used in the making of solid propellants. Chemical mixtures like these become the propelling charges for modern artillery weapons, rockets, and missiles. A variety of processing methods ensures the best size and shape propellant for the particular need. Arsenal contribution to basic research in solid fuels
plays an important part in our country's missile and space programs. Here, technicians are preparing to test the solid propellant motor for an Honest John rocket. Such tests provide our scientists with data for further development of motors and nuclear and conventional warhead components for rockets and missiles. Our ballistic range provides valuable data on performance of explosives for the Army's big guns. Ammunition developed at Picatinny may receive further tests on larger ordnance-proving grounds. Research and evaluation programs like those conducted at Arsenal Laboratories give America's scientists and engineers an opportunity to work on things not yet discovered or built. In this way, a pool of technical experts is developed, and leadership is provided to industry in creating the effective weapon systems our nation needs.
I work at the Watertown Arsenal, just outside Boston, one of several ordnance weapons arsenals. Our special activities center around research and development of metals. One of our latest research devices is an atomic reactor designed to study the molecular structure of materials. It can also, by radiation, increase the hardness and strength of metals used in ordnance equipment. Most of the experiments conducted at the reactor will provide background for more applied studies in metals at other arsenals. Whatever their individual research assignments may be, all the arsenals employ the very newest scientific techniques in discovering the best for our country's defense. In our high-temperature laboratory, for instance, we study the behavior of metals under conditions of extreme heat. This plasma jet, which can reach temperatures up to 30,000 degrees Fahrenheit, is used to test the effect of a concentrated blast of heat on metals and ceramics. Electronic induction apparatus also measures the physical properties of ordnance materials under high temperature. Arsenal technicians study the flow of electrons from metals heated in a high vacuum furnace to determine their metallic characteristics. Coating of metal with ceramic gives a higher resistance to conditions experienced in flight. A ceramic coating will protect the metallic nozzle of a rocket from the intense flame of a rocket engine. Information recorded here is essential in the development of missiles and rockets, which must withstand the tremendous temperatures and pressures encountered in actual flight. Because some plastics have a stress pattern similar to that of metals, tensile tests are performed on plastic models formed to the shape of the particular ordnance item. Effects of strain on a plastic nose cone model are carefully analyzed. Testing is done not only by mechanical means, but by optical methods as well. This polariscope measures stress through refractions of light passing through the test object. Arsenal chemistry laboratories even make use of the ancient skill of the glassblower. This technician is putting the finishing touches on a condenser. The composition of metals comes in for painstaking analysis. It may seem a long way from these research benches to the soldier in the field, but the work of Arsenal specialists is in direct support of our fighting man. In the search to provide him with the best weapons, we ensure his safety and our country's defense. In this search for the best, the Arsenals have originated many new techniques, such as ceramic cutting tools for faster, more efficient processing of metals needed in ordnance equipment. Baked in ovens under intense heat, these little ceramic cubes become as hard as diamonds. Using a ceramic cutting tool, this machine can cut or shape the hardest metal many times faster than the normal lathe with a conventional cutting tool. Many ordnance-developed processes like this one have been adapted by industry for production of civilian goods. In our metallurgical laboratories, the search goes on. Here we explore principles governing the processing of metals used in the making of weapon systems. Arsenal foundries carry on experiments in the improvement of steels by conventional casting methods. But the Army's critical need for lighter weight metals has produced new Arsenal-developed metallurgical processes, such as titanium melting and casting. This is accomplished in a carefully controlled high-vacuum furnace to prevent the titanium alloy from burning in the open air. Titanium, light as aluminum, strong as steel, is particularly effective in the production of airborne equipment. Increasing the strength of metals is accomplished here by the heat treat method. These gun tubes, which have just been removed from a processing furnace, are being immersed in dip tanks to make the steel harden properly. The mechanical testing sections of ordnance arsenals determine the tolerances of metals to destructive shock. Hydraulic testing apparatus, which builds up a pulling pressure equal to almost 2.5 million pounds, gauges the strength of various steels. To detect structural and casting flaws and defective welds in metal, powerful X-ray equipment is employed. This 2 million volt X-ray machine at Watertown can shoot through an 8-inch steel gun tube. The X-ray picture is projected by remote television for evaluation. Fundamental to maintaining the best equipped army in the world is this kind of technical knowledge and the opportunity to apply it through continuous military research. In this Arsenal fabrication shop, some of the largest machinery in the world was designed for pilot production of new and complex armament components. Watertown Arsenal scientists and technicians designed and built the retaining rings for the Saturn space probe, a project of NASA, the National Aeronautics and Space Administration. Engineered to tolerances of a 10,000th of an inch, the rings are 45 feet in diameter and will bind the multiple rocket clusters which will power our future manned space probes with a thrust of 1.5 million pounds. This rocket diffuser test assembly, built by Watertown engineers for the Air Force, is typical of the special projects undertaken by our fabrication shops for the other armed services. Improvement in conventional tooling methods is constantly pursued. Test production of ordnance equipment, like this breech ring, is facilitated by constant research in fabrication techniques. To ensure the making of a better military product for our nation's defense, the arsenals leave no research path unexplored.